So today, as we learn about parallel and perpendicular lines, we're going to learn how the slope is affected. We're going to learn how to discover if two lines are parallel or perpendicular. And then we are going to use the applications that we already learned to graph them or write an equation of a parallel or perpendicular line. Continue recording? The first thing we're going to discuss is what's going to happen as we deal with parallel and perpendicular lines. So let's say I have two lines. I have y equals 2x plus 3, and I have y equals 2x minus 1. What do you notice about these lines? So we're going to call this m1, which is going to equal 2, and m2, which equals 2. That's slope of line 1, slope of line 2. And as Ben so rightly stated, they have the same slope. Anything else that's similar here? Okay, contrast them. If there's no compare, I'm sorry, Paulo, go ahead.
I was going to say they're parallel.
They are parallel. How do we know they're parallel?
They have the same slope.
Having the same slope denotes they're parallel?
And they don't have the same y-intercept.
And they don't have the same y-intercept. Give yourself 10 net points. You accurately described parallel lines in a coordinate plane for us. They have the same what? Slope. And they don't have the same y-intercept. If they had the same y-intercept, they would be the same line. Follow? So at this point we're going to graph these two lines. So we have 2x plus 3, so it graphs at 3. And it goes up 2 and over 1, up 2 and over 1. And you would have a line that goes through those points. That's y equals 2x plus 3. If I had another line that was y equals 2x plus 3, it would overlay right on top of this current line, wouldn't it? That line would not be parallel. That line would actually be the same line. So when we talk about the same line, if they have the same y-intercept, they are not parallel, they are the same line. If they have a different y-intercept, those lines are parallel. That's why when I have 2x minus 1 down here, and the slope is still 2, even though I can't draw a straight line, those two lines technically are parallel because they possess the exact same slope. All right, so let's keep this knowledge. Let's not forget about it, and let's put it up over here in the corner. But we need to continue this knowledge. What if I had this? You see, I have 2x plus 3y equals 7. And I have y equals negative 2/3 x. Are these two lines parallel? Well, there becomes the question of, how do you tell if a line is parallel if they don't look identical yet? Tati?
You have to put it in the right form.
Put it in the right form. What for geometry is considered the right form, Demarie? So I must get this into slope-intercept form. So put that in slope-intercept form. Since we have now written it in slope-intercept form, and I can match up the slopes of negative 2/3 and negative 2/3, I can then say that the lines are parallel because the slopes are equal. Mr. Lee, this is a lot of writing for a math class. You're absolutely correct. And you should expect a lot of writing in your math classes. From here on out, every math class, you need to not just be able to do the problem, you need to be able to explain and describe what happened. So let's continue. The way to tell that two lines are parallel is, one, their slopes are congruent, or slopes are equal. However, if the slopes themselves aren't known immediately, I may have to do a quick step, such as put in slope-intercept form. Then return to step 1. However, we're going to have rule 3, and rule 3 it's our special rule. There are two types of special cases. Y equals A is a horizontal line. X equals B is a vertical line. And here's the special case. All horizontal lines are parallel. All vertical lines are parallel. But these do not have slopes that work. Okay? Well, horizontal lines have a slope of 0. Vertical lines, however, have a slope of no slope or undefined. So when I treat them that way, I then have to think, okay, so I've got all my horizontal lines, they're parallel. I've got all my vertical lines, they are parallel to each other. But here comes the introduction to our next idea, which is perpendicular. All horizontal lines are perpendicular to all vertical lines. So all horizontal are, upside down capital T, perpendicular to all verticals. This is good because when you see a building standing on the side of the road, just like it's supposed to, that's generally because it is perpendicular to the ground. We have interesting buildings that don't quite work that way, like the Leaning Tower of Pisa. It's falling over because it's not vertical. And they didn't set up a good foundation for it. The most basic form is the x-axis and the y-axis. They are perpendicular at the origin. Remember that perpendicular is noted with that right angle signature. Right angle is what degree? 90 degrees. The way this approaches our proof, however, is the following. If I was given two lines, like let's look over here. If I was given two lines such as this, I would say in the first step, I would change 2x plus 3y in that standard form into slope-intercept form, which is y equals negative 2/3 x plus 7/3. Then I would show that the slopes are equal. So I would say, given the two lines, convert one to slope-intercept form. The slopes are equal, therefore the lines are parallel. So we can still do a geometric proof. We can still have statements, we can still have reasons. They just happen to all be mathematically related as opposed to conceptual or vocabulary definition related. Okay? So to continue, we're now going to approach perpendicular. The rules for perpendicular are interesting. They're different. We're going to first look at the mathematical application rule, and then we're going to look at the conceptual, really quick decipher rule. Okay? So let's say I have y equals 2x plus 1. And I have y equals 4x minus 7. Looking at these two lines, I know that both of these seem to have a positive slope. One is going to have a relatively shallow slope, 2x plus 1, and one's going to have a relatively steep slope, 4x minus 7. Do those lines look perpendicular? No, they don't. But I can't state they are not perpendicular unless I have a very specific reason. My specific reason is the following reason, and here it comes. For two lines to be perpendicular, the product of their slope must be negative 1. Let's investigate this one. What's 2 times 4? Equals 8. Does that equal negative 1? So I can now say that the first two lines are not perpendicular. So this is a rule that we have to establish. You have to accept this rule. Two lines are perpendicular if their slopes have a product of negative 1. If they do not have that product of negative 1, they are not perpendicular. So it's a very basic statement. It's similar to that if you clean your room, you can go to the movies. If you do not clean your room, then you cannot go to the movies. It's called the inverse as opposed to the converse. So by having an inverse not being true, the original statement must not be true, or must not work for it. So let's check if the following lines are perpendicular. Y equals 4 and x equals 3. Are they perpendicular? Yes or no? By sight. Quick, come on.
Yes.
Y equals 4, x equals 3. It might not show up here for you, but I'm saying it. Are they perpendicular?
Yes.
Yes, they are perpendicular because one is
It's not.
and the other is? Okay. They are perpendicular because one line is horizontal and the other is vertical. How about this? We have y equals 4x minus 3 and y equals negative 1/4 x plus 2. We haven't done a bunch of examples on perpendicular yet, but to prove two things are perpendicular, you multiply their slopes and the numbers should come out to be negative 1. So I check. Does 4 times negative 1/4 equal negative 1? So I could say, yes, the lines are perpendicular because the product of their slopes is
Negative 1.
Can I write that? So let's do one more here. Let me show you something. Y equals 2, x plus 7. Y equals 2x minus 7. If I was given the following directions, tell whether lines are parallel, perpendicular, or neither, I would not just write parallel, perpendicular, or neither. I would have a reason for everything I've done. You have to have a reason. You can't just state something. So up here, we have two slopes that are what?
Parallel.
Two slopes that are parallel. How do I know they're parallel, Demarie? Because we haven't answered that question yet.
Well, first, they're parallel because they have the same slope and...
So, as was just stated, these lines are parallel because their slopes are the same and their y-intercepts are different. What about these two lines? Parallel, perpendicular, or neither?